Hello and welcome friend. Here we show that the geometrical interpretations of the derivative. The derivative f dash of a function at a point is nothing but the angle which made the tangent at the point with the x axis. So here we see how the derivative is the tangent at the point. Suppose that we have a curve. We have a curve. This is my curve. Suppose y equal to f of x, and this is a coordinate system. Let us take a coordinate system. Let us choose a point. Suppose this is a point P with coordinate here having coordinate c comma f of c, y equal to f of c. So we have taken the point here. So this is point L. Consider at this point a tangent line to this point. Suppose this is the tangent and this tangent is crossing to x-axis. This is my x-axis and this is my y-axis. Okay, so let us take another point. This is a Q, and draw a perpendicular to x-axis. Then this is a capital M. Now if we draw a chord, suppose this is a chord PQ. This chord makes, and this is chords. If we extend it, it's cut to the point R. Then if we draw a perpendicular to this point, this is point perpendicular, suppose N. Okay, so PL is perpendicular to x-axis, QM is perpendicular to x-axis, and PN is perpendicular to QM. This is a neighboring point. Okay, so this is f of c plus h. This is c, so this is c plus h, and hence coordinate of these points are c plus h comma f of c plus h. Coordinates of q are c plus h comma f of c plus h. So this distance is h. Okay, and this distance is f of c, right? Then we have, you can see that this Pn is nothing but L into M, and L into M equal to what? This is my H, right? Then this Q, NQ, let us find the NQ. So what is NQ? NQ is MQ minus N into M. Okay, what is MQ? MQ is f of c plus h minus NM. NM is equal to PM, PL, and PL is equal to f of c. Okay, so therefore let us see the angle tan of angle x r q. We are talking about this angle, tan of angle x r q, x r and q. This is same as, this is equal to tan of angle n p q, right? Both the this is parallel, this line is parallel to x-axis. Okay, so this is equal to, but here this tan of angle npq is nothing but q into n divided by p into n, pn, qn divided by Pn. What is Qn? We have just calculated Nq. So this is f of c plus h minus f of c. And what is Pn? Pn is nothing but h. Okay. Now whenever you can see on the diagram here, we are taken, this is my P, this is my Q, and this is an this line, this is a line, this is chords. Okay, so this is P N, right? This is an angle. So whenever this distance h tends to 0, as h tends to 0, h tends to 0 means this point m is moving towards L, h tends to 0. So when h tends to 0, this point Q is moving towards the P, and whenever the point moving towards the P, you can see that this line is moving like this. Suppose if this is my first line, and as this point transfer to this become like this, transfer to this become like this, this is like this. Okay, so whenever we approaches to P, this point P, this is point P, then this angle, this XRQ, this become tan of x, this XTP. And suppose this angle XTP is psi, this is equal to psi whenever this angle makes, when in the limit h tends to 0, f of c plus h minus f of c divided by h, this is tan of XTP, and we consider this as a psi, and therefore whenever tan of psi equal to this is a f dash of c. So friend, you can see that it is a very this tan, this derivative is nothing but the angle at the point makes by the tangent with the x axis. So this derivative denote shows that f dash of c is the tangent of the angle which the tangent line to the curve y equal to f of x at the point P makes with the x axis. So friend, I hope you get the idea of the tangent at the particular point is nothing but a derivative. Thank you friend, thank you for watching.